just in case there are, I'll minimize, just in case there are some more questions that come up, this may be helpful to have a little further detailed record of what we're going through today. So when we're dealing with arrays, there's a couple different things that we can do. One of them is we can do some reordering, and we can work on how that would actually look. So there's an example of that I've already pointed you guys to, called the bubble sort. That will be very, very useful for your program. What we're also going to do is modify this to work on, instead of just the Arduino Uno, we're going to modify this to actually take advantage of using the Circuit Playground Express. In order to work with those pins, there's a little different sort of values that we need to start using. So starting from roughly the same code here, let's focus first on step 1. And we need to also include, so we can copy and paste that code over into, back into the Arduino IDE. We can include, we don't actually need this second variation. There are two different versions of the Circuit Playground library. One is for the classic, and one is the one that's kind of currently updated for the Circuit Playground Express. So this is the one that we really have to have. So this is where we're including libraries and all the other things. And you guys aren't seeing any of this because it's stopped. There we go. Now it looks like it's working correctly. So this is where we're including libraries, and we've got a couple other features going on here. So there are two different variations of this. One has an underscore in it, one does not. We need the one that does not have an underscore in it. And we define the variables. So this is what we're doing in step 1. Step 2, this is where we set up communication. Things run once only. This is also where we have to start certain libraries and things like that. So that's what this is. This actually initializes not the NeoPixel library, but initializes the Circuit Playground library. And the commands that I'm using are library name, and then they're associated with the library name. So here it's Circuit Playground all run together. So this starts the Circuit Playground library. You can also leave your for loop set up there. It doesn't really matter for this particular part of the code. I'm going to delete the third loop that I have because we're going to construct that a little bit differently. That will, I think, be helpful for a lot of the questions that are coming up. So begin the Circuit Playground and serial read so that we can get information back, and then we set up loop 1. So this is our code that runs repeatedly. So we're going to talk about aspects of what you guys can use for the homework and how to see what's happening. I'm of course not going to completely solve homework for you, but this will at least point you guys farther in the right direction for that. So this first loop is going to do a few different things. So let's take a look at that. This is going to be the loop structure. So we're going to use our I index variable again. That's the one we're going to use most often. And then what we're going to do is we're going to use a command called set pixel color. The library itself, when you go to look up information on this, what you'll see is even if you go to like the GitHub repository that's maintained by Adafruit that's specific for this library, they will give you a list of functions. So begin, read the capacitive touch buttons, read the slide switch, set the red LED, which is just D13, left button, right button, play tone, light sensor, some of these other things. These are helpful to know that they're there, but absent of this list is a lot of the actual functions that run on the system. So there's a few things that we're going to be using that fall off of the end of all of these lists in order to make some of this stuff work. So one of those are things like set pixel color. So what this is going to do is this is going to call on the circuit playground in that library to run a function called set pixel color. And we're going to, in this loop, we're going to assign it LED pins at location I. And then I'm going to give it values of 240, 0, and 255. So those are values that don't have to be exactly the same. What those are representing is the values for essentially the pulse width for each of the colors on that LED. So you can think of it as being how intense are those values, because this is under PWM control, so pulse width modulation. The intensity of those pulse widths is going to change what those neopixels do as far as color. I'm going to strip the content out of this if statement because this is not what we want to do quite yet. So we'll come back to loop 3 in a bit.
Is this the same array example we were using earlier?
So this is why I'm pausing here for a moment, is to give everyone a chance to start catching up. The index is the same for the for loops. This is code that is derived from the array example. This is still using the same principles, but instead of going high and low for specific pins, in order to access features on the board, a lot of times, some of the time, we can just assign a specific pin number, but for the neopixels, we actually have to go through the driver that runs the neopixels themselves. So that requires running through these functions in the code instead. But this will be a thing that we can use in a lot of other examples and a lot of other assignments where we're trying to use the level of like how many neopixels are illuminated will tell us something about how much light does a sensor see or how much sound does the sound sensor see, things like that. So those are things that you guys will find helpful in terms of actually being able to see it on your Circuit Playground Express. That's why I wanted to use these examples. So loop 1 and loop 2 are essentially the same idea. They're just decrementing versus incrementing. Try and expand that slightly. So it's essentially the same code block that we're working with. Just an increment and a decrement on a loop. So loop 1 and 2 are the keys that you have to get done. We're not going to focus yet on loop 3, because I want you to focus on getting loops 1 and 2 functional. Make sure you guys have the setup filled in as well. You don't need the comments in the setup, because this is using for loops for arrays and other things. Comments are never mission critical for the actual function of the code, but they are there to tell us what we're trying to do. So loop 1 here, trying to go from lowest pin to the highest pin. Loop 2, trying to go from the highest pin to the lowest pin. So I set n as, I replaced the pin count that we were using earlier. Scroll up so everyone can see that. N replaces the pin count. Yeah. So temp is going to be used later. That's the part of the code that we're going to work on, because I want you guys to see an example and see some examples of how this array stuff does and does not work. Because it's a simple thing in you guys' mind that you're trying to attempt with this bubble sort, but I want to show you example of how that does and doesn't work, basically. So we'll use the temp in the third loop. And I slowed down the timer a little bit to 200 milliseconds.
So the pixel color is not yeah.
I'll make sure I've got the Circuit Playground Express. I want to write COM port. Once this loads, this is, there we go, it's finally compiling. Yeah, I'm gonna comment this block because I don't need it. But we'll come back to that.
Are we building our own array instead of both that touch the user input it, and if we also set in to the size of the or anyone who's that program should they be able
So ideally, the program should be able to take any size array of numbers with n. What I'm actually going to do here is I'm going to uncomment and comment the whole block. Because that'll be a little bit easier. Because this is not closing the void loop. That's why. So somewhere in there, one of them got deleted. So I'm going to re-comment this for the moment. There we go. So what that will do is that will give us most of the things that we need. That should be okay. So when you go to write that, it should be able to take any size array of information. That's the whole goal of the assignment. Because it's easy if you know ahead of time, hey, it's going to be a number, it's going to be an array of 10 numbers, right? We're using that just for the sake of it's enough that you can see a lot of changes, but it's not so many that it's completely overwhelming for you guys to type and follow along with. So it's I haven't gotten a chance to sit down and post an array because there's just been lots of other chaos behind the scenes. When you have the code operating, it should be blinking randomly, sort of like this. I'm sure everyone can see that online. So that's what you should see is your end result. That's having the third loop commented out. There's a reason that I commented that out so that it doesn't just get stuck doing nothing. There we go. So that's the first step, is now you can work with, from this kind of code base, you can work with all sorts of different ideas to use the pixels on the board. What this is going to then do is allow us to do some calculation, but we need to be able to do serial prints and all of these other things in order to make that happen. So that's what all of this business is. All right, so one of the other things that we haven't covered in great detail yet is the if statements and how some of that works. So this is another piece of information that you have to use in conjunction with the other stuff we're doing, because otherwise you just won't have enough information to make it all work. So the if statements, what we can do is we can go back to our language reference. It's going to be under their control structures. Here we go. So if gives us a logical comparison to say if condition is met, then execute statements. If x is greater than 120, then do this thing. You can write it, that's one of the few instances where if you essentially have to be one thing, if you're only doing one thing, if and only if you're doing one thing, one command, one function, one something, you can exclude the braces. Safest methodology, and the one that I'm going to teach you guys for the sake of habit, is to use these after each if statement because the curly braces are your friends, right? That's your base and your lid to the sandwich container. And that's what you want to always be using. So often in an if statement, we're doing layers of comparison from one thing to another. So we're doing one set of values. We'll learn about multiple kinds of conditions later. But this is the key for how you want to make an if statement work for you. This is the syntax that I want you guys to focus on. So what does that actually look like when we sit down to do this? So one step that we have in our comparison is we want to see if, for instance, and we have up here, we still have an array, LED pins. If this LED pins at position I is greater than LED pins at position I plus 1, so this is the previous value and the next value, or rather the value that you're looking at and the next value. Previous value technically would be I minus 1, but that can get super confusing in a hurry. So we want to see a couple different things come out of this. So the language reference, answer Alex's question, the reference we're using is array, array under the control, and the language reference is one of the other ones that if you guys haven't bookmarked this, you really need to, because the language reference under their structure, control structures specifically, is the syntax for the if statement. They have these additional comparison operators. So if something is not equal to, if something is equal to, you need two equal signs. So x equal y. So this is stuff that you would put into the condition statement. So is x not equal to y? Is x less than y? Is x greater than y? So these are the pair that we're looking at right now. Less than or equal to, greater than or equal to. So the less than or greater than always goes before the equal sign. Otherwise, it'll throw issues when you go to compile, and you'll get lots more of those red love letters that you all are coming to love. So we're going to look at this. If statements are often paired with a second set of conditions, meaning if condition do statements, and then there's an else that happens afterwards. So a way that we might think of trying to do that initially, and this is the wrong way to do it, but this is where I wanted to start you guys, is we would have an if, we would have an else, and the else is going to be just kind of the last, the else is going to be the close. So this if statement, I'm going to cut this and paste it here. I'm going to tab this in to make sure it's clear that it's going with the if statement. If, and then else. The else is another key that we need to understand. The else is referring to, I forget if they've actually got it listed. Yeah, they do here. They should, because this is a key. The if else is if one condition, do A, there's an else if, and you can look at a second condition, then do B. Otherwise is the else, do C. So often the else condition, you don't 100%, as far as I know, have to use the brackets, but it's going to keep you out of trouble with the compiler. So the else condition is going to be any other things that you're doing. So if LED pins at I is greater than the next value, the way that this is easy to think of, at least for the purposes of what we're doing here, is it's easy to think of, okay, we're going to store values to this temporary array, right? So it's easy to look at it and say, all right, so I'm going to say temp at position I, so the next index, right? Temp at position I, I'm going to assign to that if LED pins at 1 is greater, I'm going to assign the smaller value, which would be LED pins at I plus 1. I want you guys to see what this looks like first so that you guys aren't just blindly following somebody coding something and then you guys all end up falling off the same cliff after each other, because that's not my goal in this class. So if we take a look at this and we say, if we start by assigning temp at I, the else condition, I'm going to copy this for the moment and I'll make the adjustments to the code in a second. If our one condition is this is greater than, the else is obviously representing the opposite of that. So if this condition is true, then do this thing. So this is do thing A. This is do thing B. This else is meaning this runs if condition above is false. So depending on what kind of thing you're doing in that specific problem that you're working on, you can either do, this could be equal, this could be less than or equal to, whatever the comparison you need is for the problem that you're trying to solve. That's what we want to keep in mind for how this operates. So if the smaller value then, if I, location I, if that value is less than the location next to it, then leave it alone, right? This seems fairly straightforward. And there were a couple of I think actually a lot of the flowcharts that looked something like this. So I want you guys to see what that looks like. In order to print these, there's another thing that we have to do at the end of these.
A quick question.
Yeah.
So if we're, say, we finish the assignment and it's reading a program and it spits out every single time it finishes running through it, and it says the array, and then it fixes it again and fixes it again. We make it so it stops when it's correct, and it just keeps feeding us the same question.
So if you've got it correctly feeding that's a good question. If you've got it correctly feeding the end array, ideally your code shouldn't be changing it at the end. So long as you're getting to a sorted array at the end, that's what our goal is for this project. Yeah, if it does that, that's fine. So I just wanted you guys to see, there were a lot of flowcharts that actually were saying to do this, where you just reassign this value. So I want you guys to see what those flowcharts look like. So this is the flowchart that says, well, if this one is greater than, then do this. If this one's less than, then store the value to the same array, basically. So this is where I was telling you guys you needed to use a temporary array. This is how a lot of you guys were setting up the flowcharts initially. I think mostly without realizing what actually is going to happen here. So what we're going to do is we're going to open up the COM port and see what this looks like. I'm going to scroll up and show the original array. I'm going to open up the serial monitor. Oh, one of them is missing where is it? So both of those have to be terminated. That's my issue there. Yeah, that's the issue there. All right. Now I'm going to re-verify. Compiler should be happy, and I should be able to actually take a look at the COM port, scroll back up, and take a look at the differences here. There we go, it's loading, doing its thing, goes through and blinks the pattern in reverse, and then it's spitting out the array. So what's it doing? Reading the array, but what did it do with all this information? Sorted it, but did it sort it the right way? No. Where'd all those zeros come from? So this is specifically looking in the code. This is specifically looking at this LED pin array. It's looking from all these values from 1 to 10, going through this loop over and over and over and over again. This is losing information in this process. So instead of saying what this value is, actually this is LED pins at I. This is replacing and overwriting with zeros. So this would be slightly different than what some of the flowcharts had written. So let me correct this real quick. It would be taking LED pins, and if you're running the previous value, you would be storing LED pins at I to temp at I. So that should be correct. This one is where it would be, this one I think would actually need to be, what would that be? Would that be temp at I -1? No, it wouldn't be. So this is where just because you compare and look for the smaller value, this one right here, the first time it runs through, LED pins at, let's see, temp at I. This should overwrite temp at I, and this should give us a couple more values. This is a different value set than what I ended up with earlier this week when I was running this code, which is also very interesting, because this is giving me This is not memory positions, but this is giving me some interesting information. So anyway, this is a different other wrong way to approach this problem. And I wanted to show you what it looks like to overwrite the data and what I was talking about when you go to do these arrays, because you could have it print out, LED pins as well, but you have to print these out in, when you go to print an array, you have to print it inside of a for loop for a whole range of reasons, because you can't just put serial print and then temp and have it print out the entire array in that way. That doesn't work with the syntax of how these things operate. So you have to do it with print lines, and that creates all kinds of issues. So it should be pulling some additional values. And it shouldn't matter whether or not this is pre-allocated to the correct size. That's done just for the sake of computing. But remember, what I pointed you guys to was the algorithm at where? Does anyone remember? The algorithm that I pointed you guys to. Yep. Geeks for geeks. And of course, it helps if it's spelled correctly. There we go. And you can find information. So the simple bubble sort is where you want to head. And this is why I pointed you guys in this general direction, because this is the way that you actually need to do the swap. So you have to hold on to a temporary variable. You have to store some information into that temporary location. And then you have to overwrite the one that you just stored with the new information. Then that new information you overwrite with the temporary. So what you're doing is, imagine you've got, I'm going to go back to the same analogy because it's the simplest I can think of for how this has to work. Imagine you have two mugs and one is completely full of pens and pencils, right? You need to rearrange them in order of colors, but you can't because there's no space to move them, right? It's full. So what you need to do is you need to take one of those out, temporarily hold it in another place, right? And it's almost like the pegboard games, a number of other organizational game structures. You have to remove one of those elements in order to rearrange the rest of the puzzle, then put that one back. So this is the thing that you have to do. And the challenge is, now that you guys have seen most of the rest of this code to get you started, I wanted to see if you guys could implement that and do some sorting in conjunction with this blinking of the neopixels. So instead of doing it this way, I want you guys to set this if condition up, and I want you to do it the right way. So I'm just going to leave this. And that's what I want you guys to work on filling in, is how to do the right thing inside this algorithm. So we'll have everyone joining us in just a second or two here. Everybody's officially back. So what I want to do real quick is highlight that if you guys were to just copy their for loop, for instance, and try to paste that into your code the way it is, it's going to throw all kinds of errors. And where a lot of students, I think, are encountering troubles is they're trying to do something sort of like that. What each of these is called a function. That's what this is telling you about. This sort function, what it does is it goes through, there are two different integers and two index variables. It goes through one loop and says for this value, this index j, starting at the same starting point that this is, 1 less than n minus I. So the difference between, in this case, it's 1 less than I. So it's never overrunning the loop that it's inside. That's why this has to be n under 1. They swap, and what you can do instead is this is calling another function. So this is a function, it calls another function. You can develop this code inside of your if condition, because that's what this is doing. So you don't have to write the external function. If you try and just drag and drop the code, it's not going to work for good reason. So outside of writing separate functions, it behooves you to instead replace the function with just its actual code and then translate it over to variables that you are using in your process, so that then you can run through and test it with an array of some size. So I may get a chance later this afternoon to post an example array that I want you guys to solve. I don't know for sure. I should be able to find a few minutes to do that. But what this is going to do is this is going to allow us to use an array of whatever different size if we have a properly set up loop structure. So the trick is how to implement this part correctly, and that's the thing that I want you guys to be focusing on. So I wanted to address that because that was a couple things that were that some groups are struggling with. So what other questions are coming up as you guys are working on this?